Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 6 video on the topic of area of trapezium and polygon, where I will discuss about how to find the area of irregular polygons. In the previous part, part 5, I discussed about how to find the area of a quadrilateral. And if you have not watched all the previous parts, I strongly suggest and request that you please watch those videos also to maintain the continuity of this chapter, that is area of trapezium and polygon. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel. And also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with the part 6 video on area of trapezium and polygon, where I will discuss about how to find the area of irregular polygons. Okay. So we will discuss about how to find the area of irregular polygons. Now polygons, since we have already discussed quadrilaterals, which is a polygon of 4 sides, in this video by irregular polygons we will mean polygon having number of sides greater than or equal to 5. So the fundamental concept of finding the area of a polygon is to divide the polygon using the diagonals, divide the polygons into triangles, rectangles, trapezium or parallelograms, and then find the area of the individual triangles, trapeziums, rectangles and parallelograms and add their area. So in the given problem, the dimensions will be very specific. That is, in the given problem, in the given figure, the diagonal will be already mentioned, using which you have to find the area. So the selection of diagonal depends on the given problem. So how is actually the area of a irregular polygon found, calculated using a diagonal and by constructing triangles, trapeziums, rectangles or even parallelograms. So let's consider this ABCDE is a pentagon, is an irregular pentagon. So how do we find the area of this polygon, that is pentagon? So we can, since there are many diagonals, we can use any one diagonal. So let's say I'm using the diagonal EC. I'm using the diagonal EC. So this diagonal EC has divided the pentagon into the quadrilateral ABCE and ECD. Okay. Now what we do is, the concept is we draw one diagonal, and from all the vertices we draw perpendicular on this diagonal. That is, in this figure we have the diagonal EC, and we can draw perpendiculars from the vertices A, B and D on this diagonal EC. So let's draw the perpendicular. So let's say AF is perpendicular to EC. Also let's draw perpendicular from B on EC. So let's say BG. So BG is also perpendicular to EC, and from the vertex D we draw perpendicular on the diagonal EC. Let's say this be H. So DH is also perpendicular to EC. So by drawing the diagonal EC and the 3 perpendiculars, we have, as you can see, we have constructed triangles and a trapezium. Now what will be the area? So please note that AF is perpendicular. AF is perpendicular to AF is perpendicular to EC, and BG is perpendicular to EC. This will imply that AF is parallel to BG. AF is parallel to BG, and so this will imply that ABGF is a trapezium. It is a trapezium, since one pair of sides in the quadrilateral ABGF, we see that AF is parallel to BG. So ABGF will be a trapezium. So now what will be, and we have AF perpendicular to EC and BG perpendicular to EC. Now the area of the trapezium, now let's consider the height of the perpendiculars or the length of the perpendiculars. Let's say AF is H1, BG is H2, and HD is H3. That is, the length of the perpendiculars are H1, H2 and H3. Now the area, as you can see, the diagonal EC has divided the polygon into one triangle, that is EDC, and another quadrilateral ABCE. Further, the quadrilateral ABCE has been divided into two triangles, AEF and BGC, and the trapezium ABGF. So the area of the whole pentagon, that is ABCDE, will be, we can say that area of ABCDE, this means, in short, I am writing area of the pentagon ABCDE will be equal to the area of triangle AEF plus area I am using this symbol for trapezium, ABGF plus area of triangle BGC plus area of triangle EDC. I hope visually you will appreciate this fact that the area of the entire pentagon ABCDE is equal to the sum of the area of triangle AEF, the area of triangle the trapezium ABGF, and the area of triangle BGC, and plus the area of triangle EDC. Now we can easily find the area of the triangles and the trapezium, because in the trapezium ABGF the length of the parallel sides are H1 and H2. But also please note that to find the triangle of to find the area of the triangle AEF, we need the length of the base AE. We need the base EF. EF must be known. Also, to find the area of the trapezium, we need to find the perpendicular distance between the parallel sides, which is FG. So all these distances will be given in the problem. This length we will need. So this is the basic concept. How we calculate the area of a irregular polygon. Okay. Now same polygon, if we consider another diagonal, let's say if we consider the diagonal AC this time. Now in the given problem, we need not sometimes we need to draw the diagonals and form and drop the perpendiculars and form the triangles and the trapezium, and in some problem already the diagonals will be mentioned. It will be given in the figure. The figure will clearly show which diagonal to use and which perpendiculars to use. Okay, So if in the same pentagon, if I consider the diagonal AC, then we see that the diagonal AC has divided the pentagon into triangle ABC and the quadrilateral AEDC. Now the idea is, from all the vertices we will drop perpendiculars on this diagonal AC. So from B, let's say the diagonal B, the perpendicular B, BE. Similarly, from the vertex D, let the perpendicular on EC be DF. Similarly, we will drop perpendicular from E to AC, let's say this be G. So in the same way, we will in the given problem we will have the length of all these perpendiculars, that is EG, BE and DF, and also the length of all the bases of the triangles, and also so the dimensions will be given, enough dimensions will be given that you will be able to find the area of the triangles, the trapezium or any rectangles formed to find the total area of the polygon. Now so this is the standard way of finding the area of a irregular polygon, but sometimes in a given sometimes the polygon, so this example polygon was convex polygon, that is the angle of all the interior angles are less than 180 degree. But sometimes in some polygon, in some figure in the problem, some interior angle could also be the polygon could also be concave, that is any interior angle of the polygon could be more than 180 degree. So in those cases we have to just draw we have to wisely draw the diagonals and form triangles and trapezium rectangles so that we can easily find the area of the whole polygon. So for this, if we select AC as the diagonal, the area, we can see area of the pentagon ABCDE will be equal to area of the triangle ABC plus area. Please note that EG is perpendicular to AC and also DF is perpendicular to AC. So FD will be parallel to EG. So if EG and FD will be the parallel sides of the trapezium EGFD. So area of triangle AEG plus area of triangle DFC plus area of trapezium GFDE. From the given dimensions, we can easily find the area of all these all the three triangles and the trapezium, and adding them we will get the area of the whole pentagon, that is ABCDE. This is the basic idea. Now let's try to see with few complex irregular polygons how are we calculating the area. So let's say in this the first polygon is having 1 2 3 4 5 6. So this is a hexagon. ABCDEF is a hexagon, and let's say we are given in the problem, the figure, the diagonal FC is drawn, and also the perpendiculars from all the other vertices, that is ABED, on this diagonal FC is given or drawn. So we are having, let's say this is perpendicular. My drawing is very approximate. It will never be accurate. So please keep this in mind. And let's say AG is perpendicular to FC, BH is perpendicular to FC. Let's say EI is also perpendicular to FC, and DJ is perpendicular to FC. So we can see that we will see that above the diagonal FC we have two triangles and one trapezium. Above the diagonal FC, the trapezium is AB HG, where AG is parallel to BH. Below the diagonal FC, we have two triangles and one trapezium, where the trapezium is DH, and the parallel sides are EI. Sorry, the below the diagonal FC, the trapezium is DE, and the parallel sides are IE and JD. So we will have area of the hexagon ABC D E F will be equal to area of triangle AFG plus area of triangle BHC plus area of trapezium ABHG. So this is the total area of the figure above the diagonal FC. Now below the diagonal FC, the area will be area of triangle FEI plus area of triangle JDC and plus area of the trapezium DJ. So this way we have a diagonal and we have all the perpendiculars drawn from all the other vertices on this diagonal, and so we will see there will be triangles and trapeziums, or even rectangles or parallelograms in some figures formed, and the final area of the whole polygon will be the sum of the areas of the constructed triangles, trapeziums, rectangles, parallelograms, or any other known figure whose area we can easily find. Now, so the next figure is we are having how many sides? This is a heptagon. We are having 7 sides. So in this figure, let's see if we are considering the diagonal FC, how we draw the perpendiculars on FC, on the diagonal FC from all other vertices, and find the area. So let's say G. So we draw perpendicular from G on FC. Let's say this be GH. We draw perpendicular from A to FC. Let's say this be I. AI is perpendicular to FC. GH is perpendicular to FC. Also, we draw perpendicular from B on the diagonal FC. Let's say this be BJ, and from the vertex E we draw perpendicular on FC. Let's say this be K, and finally from the vertex D we draw perpendicular on FC. Let's say this be L. So please note that GH will be parallel to AI, will be parallel to BJ, because all the perpendiculars GH, AI and BJ, they are all perpendicular to the diagonal FC. So these three perpendiculars will be parallel. Also these two perpendiculars will be parallel, that is IE will be parallel to LD. So above the diagonal FC we have two triangles and two trapezium, and below the diagonal FC we have two triangles and one trapezium. So in this figure the area of the heptagon ABC D E F G will be equal to, I am in short, for area I am in short writing AR. So area AR, GFH, triangle GFH plus area trapezium GHIA plus area trapezium AIJB plus area of triangle BJC. So this is the whole area of the figure above the diagonal FC, and below the diagonal FC we will have area of triangle FEK plus area of the trapezium KE DJ, and finally the area of triangle JDC. Not JDC but LDC, and also the trapezium will not be KEDJ but it will be KEDL. So above the diagonal FC we have two trapeziums and two triangles, and below the diagonal FC we have two triangles and one trapezium. So we add area of all the triangles and trapezium. That will give the area of the entire polygon, that is heptagon ABCDEFG. Now sometimes in a problem this method of drawing drawing one diagonal and the perpendiculars from all of the vertices to the diagonals, it will not work. You have to observe the given figure, and from the given dimension you have to wisely see how you will form rectangles, triangles and trapezium or parallelograms from the given figure and find the total area. For example, in this figure, consider this figure. This is a 1, 2, 3. This is a, how many sides are there? 1, 2, 3, 4, 5, 6. So this is a hexagon. This is a hexagon ABCDEF, where, as you can see, that AB is perpendicular to BC. DC is also perpendicular to BC, and the dimensions are given. The length of AB is given as small b, the length of DC is given as small a, the length of BC is given at the length of, as you can see. So what are the dimensions given? AB, consider this as a given problem. So how do we find the entire area of this polygon, that is the hexagon ABCDE? So given that AB is b and the DC is equal to a, and we are given, so let's say, so FE, the side FE, and also it is given that FE is parallel to BC, AC is parallel to BC. Okay. So we have this, and AB is given perpendicular to BC, and this DC is also perpendicular to BC. Okay, and it is given that FE is parallel to BC. Now, FE is parallel to BC. If we extend FE on both sides, let's say it meets DC on at G, and it meets AB at the point H. So we will have EG will be perpendicular to DC, and we'll also have HF perpendicular to AB. Perpendicular to AB. Okay. So how do we find the area of this hexagon? Now, if we notice that also some other dimensions are given, it is given that AE is equal to x, EG is equal to y, EG is equal to y, AE is equal to x. Okay. And also it is given HF is equal to Z. So clearly we can have FE will be equal to AE minus AF, which is equal to x minus Z, and also BC we can see is equal to x plus y. Now notice that so we have one rectangle HB, so we have two triangles, so we can say that the area of this entire polygon, that is hexagon ABCD EF will be equal to the area of triangle AH okay. Now from the given dimension we have to wisely create the some figures, that is triangles or trapeziums or rectangles, so that we can easily find the area. Now I was thinking that I can consider the rectangle HBCG, but I know BC, but I do not know GC. I cannot find GC. So, but if you see that if I join FB and EC, then FECB is a trapezium. FECB will be a trapezium where FE is parallel to BC, and but we need to know the distance of the parallel sides FE and BC. So I was thinking that the area of ABCDEF will be equal to area of triangle. I am just discussing how from a given figure and given dimension we have to wisely create triangles or trapezium or rectangles, so that we can easily find the area of the individual triangles, rectangles, trapeziums or parallelograms and find the total area. So I am not in this example I am not trying to solve any problem. So this will be area of triangle ABF plus area of triangle DEC and area of trapezium FBCE. But for the trapezium, if FBCE, we know the length of the parallel sides, that is FE and BC, but we do not know from the given dimensions what will be the perpendicular distance between the parallel sides. The triangles we can find, because for the triangle ABF, the base we can consider as AB, because FH will be perpendicular. So this is FH is perpendicular to base AB. So we can find from the formula half base into height. HF we know is Z and AB we know as B. Similarly, for the triangle DEC, we know that EG is perpendicular to DC. So we can consider DC as the base and EG as the altitude. So the area of the triangles is no problem, but for finding the area of the trapezium FBCE, we need the height of the trapezium, that is the distance between the parallel sides, whose value is not given, but anyway it will be given in the actual problem. I am just discussing how the different ways that we need to think to solve in finding the area of any irregular polygon by forming triangles, rectangles, trapezium, or even parallelograms, whose individual area we can find from the given dimension. Okay, now let's solve two examples. The first problem says that, so we are given a pentagon. In this pentagon ABCDE, the perpendiculars on AD is that is BF, GE and CH are in the ratio 2:2:3, 2:2:3, and the line segments AF and the line segments AF, FG and GH and HD are in the ratio 1:3:2:2. If A1 is equal to area of ABCD, the quadrilateral ABCD, and A2 is the area of the whole pentagon ABCDE, then find the ratio A1 is to A1. A1 is to A. That is, we have to find the ratio of the area of the quadrilateral ABCD and the area of the whole pentagon. So we are given that the perpendiculars, the ratio of the perpendiculars, and the ratio of the distances that are being formed by the foot of all the perpendiculars on the diagonal AD. Okay, so we know that above the diagonal AD, BF is parallel to CH, since they are both perpendicular to AD. So we have the trapezium BCHF. Okay, now since the ratio of all the perpendiculars are given, let's say the length of the perpendicular BF, so let BF be H1, CH be H2 and GE be H3. We have three perpendiculars. So let, just for the sake of just to refer the length of the perpendiculars, we are assuming that let BF we are given the ratio of the perpendiculars, so it's better that we use the concept of ratio and proportion. So since the ratio of the perpendiculars BF, GE and CH are given as 2:2:3, so let BF is equal to 2x, GE be equal to, this is based on the given ratio, 2x, and let's say CH is equal to 3x. So whenever we solve any problem based on ratio and proportion, we know that if the ratio of some quantities are given and we need to find the value of those quantities, we usually, using the parts of the ratio, we assume the value of each of those quantities as a multiple of x using the parts of the ratio. So in this case, we have used the parts 2, 2 and 3 in the given ratio. So BF is 2x, GE is 2x and CH is 3x. Also the ratio of AF, FG, GH and HD are given. So since this is a different ratio, we cannot use x in assuming the values of AF, FG, GH and HD. We have to use some another variable. So let's say AF, again based on the given ratio, AFB 1, so y, FG, its corresponding part is 3, so let's say FG is 3y, GH is 2, so let's say 2y, and HD is also 2y. This is based on the ratio of 1:3:2:2. Okay. Now for the triangle ABF, we need BF, which is 2x, we need the base length of the base AF, which is y. Okay. For the trapezium BFHC, we need the distance between the parallel sides, which is FH. So let's see what is FH. FH is equal to FG plus GH, which is equal to 3y plus 2y, which is equal to 5y. Okay. Also, we will need HD, and HD is we already given. HDV is 2y. Okay. So, what will be the length of the entire diagonal AD? AD is equal to AF plus FG plus or rather AF plus FH plus HD. This is equal to AF is y, FH is 5y, and HD is 2y. So this is equal to 8y. So AD is 8y. Why we are calculating the length of the diagonal AD? Because we need to find the area of the lower triangle, that is AD. Now remember that in the given problem, the ratio of we need to find the ratio of the quadrilateral ABCD and the entire pentagon, that is ABCDE. Okay. So what is now area? Therefore, area, in short I am writing AR, area of ABCD, that is the quadrilateral above the diagonal AD, is area of triangle BAF plus area of trapezium BFHC plus area of triangle CHD. So this will be the area of the quadrilateral ABCD. Now what is area of triangle BAF? It will be half multiplied by BF. BF is 2x multiplied by base AF. What is AF? AF is y, plus what is the area of triangle the trapezium BFHD. So we know the area of a trapezium is half into the length of the sum of the parallel sides and the height. So what is the sum of the parallel sides? It is BF plus CH. BF plus CH. BF is 2x and CH is 3x multiplied by height is FH. FH is 5y plus the area of the triangle CHD. It is half the perpendicular is CH, which is 3x, and the base is HD, which is 2y. So if we simplify this, this will be the area of triangle BAF becomes xy. The area of trapezium BFHC becomes 2x plus 3x. What are the parallel sides of the trapezium BFHC? BF is 2x and CH is 3x, 5x, and FH is 5y. FG plus GH. What is FG? FG is 3G, and GH okay. I was not expecting this to be as, so we are having 5x by 2 multiplied by 5y. I was not expecting the denominator 2. So while I was framing the question, I might have done something wrong in giving the value of the ratio. Let me check again once again if I am using the ratio properly or not. So it is given BF, GE and CH 2:2:3. No, AF, FG, GH, AF, FG, GH and HD are in the ratio 1:3:2:2. So AF is Y, FG is 3Y, GH is 2Y and HD is 2Y. This is fine. So what is HD is 2Y, what is GH? GH is 2Y, 5Y. If FH is 5Y, it is fine. Anyway, so this plus we are having the area of the triangle CHD as 3xy. So this is equal to 4xy plus 25xy by 2. Now the answer will come very weird. Anyway, so this is equal to, if we simplify this, 8xy plus 25xy by 2, which is 33 by 2 xy, is the area of the quadrilateral ABCD. Now what will be the area of the whole pentagon ABCDE? For that we have to find the area of the triangle AED. Now area of triangle AED is equal to half AD is the base, AD is base. What is AD? AD is 8y multiplied by what the height is GE, which is 2x. This becomes 8xy. Therefore area of ABCDE, that is the whole pentagon, is area of the quadrilateral ABCDE plus the area of triangle AED. The area of the quadrilateral ABCD was 33 by 2 xy and the area of triangle AED is 8xy. If we simplify this, it becomes, so if it is given that if A1 is the area of ABCD, so 33 by 2 xy is A1 and the area of the ABCD, that is the pentagon whole figure ABCD, is if we simplify this, 33xy plus 16xy divided by 2, which is 49. Very weird values are coming, fractions are coming. Anyway, 49xy by 2. Okay, this is given as A. So this implies A1 by A will be equal to 33 xy by 2, this divided by 49 xy by 2. Xy by 2 will cancel out from both the numerator and the denominator and the ratio will become 33 by 49. So this implies A1 is to A is equal to 33 is to 49. Okay. Let's see the next problem. The next problem says that in the hexagon, so we are having a hexagon ABCDEF, that is there are 6 sides. In the hexagon ABCDEF, EI is perpendicular, so EI is perpendicular to AD, FG is perpendicular to AD, CH is perpendicular to AD. So we are having 3 perpendiculars drawn on the diagonal AD, and the length of all the perpendiculars are given. EI is equal to 2x, FG is equal to 4x and CH is equal to 5x. And AB, okay, we also see that AB is perpendicular to the diagonal AD. AB is perpendicular to the diagonal AD. Also, the perpendicular CH is also perpendicular to AD. So we must have HC parallel to AB, which means that HABC is a trapezium. Where the parallel sides are HC and AB and the height is HA. Okay. Now what else is given? AB is given 3x, DI is equal to DI is equal to IH is equal to HG is equal to GA. Okay. So DI is equal to IH is equal to HG is equal to GA. If area of ABCDEF is A, then AD equals. So the area of the whole figure ABCDEF is the whole hexagon. Its area is given as A. Then we are asked to find what will be the length of the diagonal AD. So the dimensions of all the perpendiculars and all the bases are more or less given. Okay. Fine. So we can see on the left hand side of the diagonal AD we are having two triangles and one trapezium. As we know that since EI will also be parallel to FG, since they both are perpendicular to AD. So EF GI is also a trapezium. Now we know the dimensions of the perpendiculars in terms of x, but we do not know what are the actual values of DI, IH, HG and GA. We need these dimension values, the length of these segments to calculate the area. So let's say since DI is equal to IH is equal to HJ is equal to GA, please note that it is given, we know that what is AD? AD is equal to DI plus IH plus HG plus GA. Also it is given that DI is equal to IH is equal to HG is equal to GA. So this will imply that all DI, all these segments, that is DI, IH, HG and GA will be equal to 1/4 of AD. IH is equal to HG, whatever the length of GA will be, this will be equal to AD by 4. So let's say AD by 4. Now let the length of AD be equals to y, just for the sake of calculation. It will be easy to refer. Let AD be equals to 4. So we have all this length y by 4. Okay, now let's calculate the area of the whole figure, that is the hexagon. Let's calculate the area of all the triangles and trapezium one by one. So area of triangle EID, area of the triangle EID will be equal to the perpendicular, the altitude is 2x, that is EI is 2x half multiplied by 2x plus base multiplied by base is ID, which is equal to y by 4, This is equal to xy by 4. Okay, let's see what is the area of triangle FAG. It will be half into altitude is FG, which is 4x, and base is GA, which is again y by 4. this will be equal to xy by 2. Okay, and what is the area of the trapezium? We have the trapezium EFGI on the left hand side. EFGI will be equal to a half into the sum of the parallel sides. The parallel sides are of length 2x and 4x. 2x 4x multiplied by the distance between the parallel sides, which is IG, Now what is IG? IG is equal to IH plus GH. So IG will be, note that IG is equal to IH plus HG, which is equal to y by 4 plus y by 4, which is equal to y by 2. So we have y by 2. This is equal to half into 6x multiplied by y by 2. This is equal to 3xy by 2. 3xy by 2. Okay. Now let's find what are the area of the triangles and the trapezium on the right hand side of the diagonal AD. So we have the triangle. We have only one triangle and one trapezium. So DHC. What is the area of triangle DHC? The height is, altitude is CH, which is 5x, and the base is DH, which is again DI plus IH, which will be y by 4 plus y by 4, that is y by 2. DH is y by 2. So half multiplied by 5x multiplied by y by 2. Okay. Which is equal to 5x by 4 divided by 5xy by 4. And what is the area of the trapezium? On the right hand side, we are having the trapezium HABC. HABC. It is half multiplied by the sum of the parallel sides multiplied by the altitude. So what is the sum of the parallel sides? The parallel sides of the trapezium on the right hand side are HC and AB, and they are of dimension 5x and 3x. So we have 5x plus 3x. And what is the height of the distance between the parallel sides? It is HG plus GA, that is again y by 2. Y by 2. This is equal to half 8x multiplied by y by 2. This is equal to 2xy. So therefore, the area of the hexagon, the area of the total figure, that is ABCDEF hexagon, will be equal to the area of all these triangles and trapezium. So it will be xy by 4 plus xy by 2 plus 3xy by 2 plus 5xy by 4 and plus 2xy. I think I might have done some calculation mistake, or I have given the choices incorrectly. Let me see. I don't think my answer will match with any of the choices, but that is not important. The important thing is how I am approaching the problem and solving it. So this is, if I simplify this, what will be the LCM? LCM is 4. We have xy plus 2xy plus 6xy plus 5xy and plus 8xy. So this is equal to 3, 9, 9, 14 and 22. So 22xy by 4. 22xy by 4. Okay. So this is the area of the entire hexagon. Okay. And what we have to find? We have to find what is AD. That is, we have to find A, because we have assumed the length of the diagonal AD is y. We assume length of the diagonal AD is y. And it is given that the area of the whole figure ABCDEF is A. So we have to find y. Okay. So this implies that 22xy by 4, this is the area of the whole figure hexagon, which is equal to A given. So this implies y is equal to 4 by 22 x multiplied by A. If we divide by 2, we have 2a by 11x. Do we have this choice? 2a by 11x. Okay. So the choice is B. B is the correct choice. So this was two problems based on how are we using the fact of concept of finding the area of irregular polygons from one diagonal and the perpendiculars drawn on that diagonal from other vertices of the polygon, and the area of the whole irregular polygon will be the area of the triangles, the multiple triangles, trapeziums, or even in some figure it will be rectangles or parallelograms formed, and we add those areas. So this is all about finding the area of an irregular polygons. Even though it will be very problem specific, it will depend a lot on what diagram is given and what dimensions and what data are given. Accordingly, you have to form the triangles, trapeziums and rectangles by joining some vertices or line segments that you have to observe, and accordingly proceed to solve the problem. It will be clear when I will solve more problems on finding the area of some irregular polygons. So I hope this video was beneficial. If it is so, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I will discuss about how we find the area of regular polygons, that is a polygon of sides greater than or equal to 5 where all the sides are equal. That is, a regular polygon is where all the interior angles are equal and all the exterior angles are equal. So the concept will be same. We just divide the entire regular polygon into some rectangles, triangles, trapeziums in a wise way, so that we can find the area of the individual triangles, trapeziums, rectangles, and then add them up. That I will discuss in the next video. And once that is complete, I will solve the problems of the next exercise, which will be exercise it will be exercise 18b and then exercise 18c from the chapter of area of a trapezium and a polygon from the textbook of author RS Aggarwal. So these videos are coming soon, so please stay tuned. I will end the video here. Thanks for watching, and until the next video, take care and bye.